Everybody, Dr. A here, and in this video we're going to be exploring an example of how to sketch free body diagrams for 2D rigid bodies. So let's go ahead and get started. In the given information, we're being asked to sketch the free body diagram, or as we abbreviate it sometimes, FBD, for each system. Now here we've got 6 systems that we were given: A, B, C, D, E, and F. So we're going to sketch the free body diagrams of each one of these 6 systems, but we're not going to do anything else. We don't have to solve for unknown reactions. All this is just to practice sketching free body diagrams. So let's go to get started on the solution. We're going to start with saying solution, and we're going to start with A. So the beam in A is called a simply supported beam. It's called that because at each of its 2 ends, it is supported by a pin at one and a roller at the opposite end. So we're going to make a note here. We're going to say this is called a simply supported beam, and its free body diagram is going to be relatively simple. At point A, we had a pin connection, so that's going to give us 2 force reactions, an AY and an AX. Remember, a pin support is characterized by this triangular shape. And then at point B, we had a roller, and a roller has a normal force that is perpendicular to the surface that the roller is resting on, okay? So because the surface the roller is resting on is this horizontal surface, it's going to develop a normal force that is vertical here, okay? Now, in our free body diagrams, we always sketch on there the known forces as well. So we have this known force P, and we also sketch any given dimension lines in our free body diagram. So that's 0.7 L and that's 0.3 L. And that is the solution to part A, okay? So let's move on. Let's move to part B of the solution. Part B is what is known as a cantilever beam. A cantilever beam is a beam that is free on one end and it is fixed connected on the opposite end. So examples of cantilever beams that we see kind of out and about would be beams supporting balconies of structures. Those are typically cantilever beams. So this fixed connection is going to develop 3 reactions: a force reaction in the vertical direction, a force reaction in the horizontal direction, and a moment reaction. So let's go ahead and sketch that out, and I'm going to make sure we label this. This is a cantilever beam, okay? And we're going to go ahead and sketch that geometry out. And at that right support, we're going to have an AY, an AX, and a moment reaction at A. So those are the unknown reactions. And then we also need to include on there the known values. So we know that there's a uniform load here given to us as 0.3 KLF. And we also know the length of this beam is 10 feet. And that is the solution to part B. Now, I want to use this as an opportunity to remind ourselves, even though we know how many reactions we have and where they are, what do we not know about them? Well, we don't know exactly their direction. Remember, whenever you sketch these unknown support reactions on your free body diagram, at first, you really don't know for sure if they're pointing in this particular direction. So, for example, AY, I'm assuming it's pointing up here, but it could very well be pointing down, okay? So what you do is you sketch the unknown support reaction in a particular direction, and then later on when we get to examples where we do calculations, if you calculate one of these supports as a negative value, it's actually going to be pointing in the opposite direction of what you sketched on your free body diagram. So keep that in your back pocket. We're not going to dive into that really in this video, but we're going to see that a lot in later videos. Okay, let's move on to part C. Part C here is this beam. You have this kind of free end over here with an applied load P here. You have a pin at A, and then this segment AB is at an angle theta, and the roller B is on an inclined plane, okay? So if I were to sketch this free body diagram, I'm going to sketch the general shape here and here, and I'm not going to forget my angle theta. I'm not going to forget that known value of P. Now, that hinge at A, what do I have? I'm going to have an AY that develops and an AX that develops at A, okay? What about B? Well, B is a roller, and for rollers, I'm going to have a normal force develop that is perpendicular to the surface that the roller is acting on. So for that roller at point B, I'm going to have a normal force right here, and I can call that N sub B, and that's at a right angle here. And that's my free body diagram of part C. I don't think we were given any dimension lines here, so that's all we can do. We don't know these lengths, so we can't really write anything if we don't know it. Let's go to part D. D is a frame, okay? We have a hinge connection at point A down here. We have this rigid joint at B, but notice that B is not an external reaction. That's just a solid rigid joint. And then C is a roller. So we can sketch that out. Let's say part D here. And we have that uniform load W there. And we have an AY, an AX, and a CY. And why do I know that that's a vertical reaction at C? Well, again, my roller is sitting on a horizontal surface, so I'm going to develop a force that's normal to that surface, perpendicular to that surface. Okay, let's move on to part E. Here we have this beam that is supported by an external hinge at point A, and then at point B, I've got this weightless link, okay? And so what is this going to look like? Well, if I draw the free body diagram of that beam, point A is going to have, of course, an AY and an AX, and that weightless link is going to have a tensile force here along the line of action of the link, which means it's at that 60-degree angle, okay? So I'm going to call this maybe F sub B, and I need to include that 60-degree angle there, and I had that point load here. I believe that was 20 kilonewtons. And then I was given some dimension lines here of 3 meters and 3 meters. And that concludes part E. Now, again, you could kind of zoom in and draw the free body diagram of this hinge over here. Basically, that link force would just decompose into X and Y components at that hinge, but I'm really just drew the free body diagram of the beam itself, okay? Now, last part F. We have a beam segment here. Oops. We have a beam segment here. On the left, it's supported by a hinge, and on the right, it's supported by a smooth contact surface at point B here at an angle theta, okay? So what is that going to look like when I draw my free body diagram? Well, we're going to have the beam segment here. That external hinge is going to have an AY and an AX, and that smooth contact surface is going to develop a normal force in B. Now that normal force, remember, is going to be at a right angle to that surface that is at an angle theta, okay? And then we have the applied load and the length here, so we know that that's a length L, and that's the applied load W, okay? So that summarizes this quick example. Again, this is just to illustrate how we can quickly sketch free body diagrams for two-dimensional rigid bodies. This did not involve actually solving for those external support reactions. We're going to save that for some other videos. Hopefully you found this helpful. If you did, please hit like and subscribe and be on the lookout for other content like this. Thanks for watching.